Hello, hello. Okay, now I had a schedule issue this morning. I didn't make it to 3D printing. That won't happen again. If it does, I'll let you know for sure. What I want to do is go over the stuff I want to talk about today. I have a whiteboard here that I will hold up and I will use. And we're going to go over the first section of the book. This is pages 6 to 26. And that's what I was supposed to go over today. I just didn't because it wasn't there. We'll get to it this way. Take some sugar to get me going. And let's talk about. So in the introduction, they just look at the types of manufacturing techniques. And really, when you make something, you make it 3 different ways. You do forming, formative, we'll call it, subtractive, and additive. And we're going to discuss each one of those, and I'm going to write details like I would on the board. I want you to know that, get the camera right, those are the ones we want to deal with. And, okay. Formative, subtractive, and additive. Now, what is formative? Those are molds. So if you're not molds like on bread and stuff when you leave it in the refrigerator too long, these are molds that you would stick stuff in, something liquid or something that's kind of a gel, and you let it dry and then it forms something else. You take it apart and there you go. And a lot of plastics, high density, like this Sierra Mist bottle was probably formed by what's called injection molding. They have a mold for this. They basically coat the inner part inside of that mold with this plastic material, and a lot of times they'll put a balloon inside it, that mold, and they'll blow up the balloon and now push all the plastics to the outside. And by pushing it to the outside, that's how they get this way. Let me see, this formed, that looks like maybe the edge of the mold right there. You can actually see, you can't see, but there's an edge of the mold right there. Okay, so there's an edge running down it. Yeah, you check that out. That's the edge of the mold. So this is definitely molded. That they blow up that balloon that pushes it out. They apply heat or have a chemical reaction occur that solidifies it, and there you go. That's how you produce a lot of plastics. Problem with molds, making the mold, they call it the negative, is very expensive. That costs a lot of money, and it needs to. The mold has to work for a long time because you don't want to be changing it around a lot. So when it is expensive because it lasts so long. Molds, formative or mold making type things are very good for parts you're going to make a lot of. If you're just doing 5, 10, 20, 100 even, it's not worth it. It's too expensive. It's too expensive a manufacturing technique. So there needs to be other ways. Now you can cut metal. I had a piece of something that was manufactured, and it's really cool. And I just knocked my camera off. So, yeah, that would happen, wouldn't it? Now, this is pretty cool. This was actually machined. It was CNC machined. This is the point where it was a guy gave me this, and it was actually machined. It was cut away from a solid block of aluminum. And now this one, the thing it sat on turned, and the tool didn't just come in. It could flip over and go in on the sides. I mean, this is pretty cool stuff. It's called a 5-axis machine. It may have been, they have lots of different ways of doing a 5-axis, but this is when you cut things away. That's subtractive manufacturing. Machining, when you think of a lathe, a mill, a drill, a saw, those sort of things, when you cut it up, whittling, I don't know if you guys do any whittling in there. That's what the old people would do. They'd had a knife and they'd cut and make spears and stab each other or just poking each other with it. That's before you had social media and you could poke people. Now, back then, you just whittle something, you physically poke people. Hopefully, you get a fight. Now, that is subtractive manufacturing, cutting stuff away to make something. Additive manufacturing is, kind of what we're going to be doing. One of the things I'm trying to come up with a way of thinking of it, if you take Play-Doh and put it into a shape, put it on something, stick it here, and you put a bunch of Play-Doh things together and you make something. Mr. Potato Head is additive manufacturing. You're adding pieces, parts, and you make something. So you put it all together. Now, of course, Mr. Potato Head, you can pull the pieces apart. Play-Doh, you can to some extent pull it apart. 3D printed parts, this is an ejection charge well for some rocket stuff we do. This was done via 3D printing. Now this was made by adding layers. Done it in layers. I don't know if you can see from focus, you can get an idea of some of the layers of the layering. Yeah, you can kind of, there you go. In the light, you can see it. Now, this layering, making the layers, was made, that's how 3D printers work. Additive manufacturing works very good for small batches, prototypes. It's fairly cheap. Subtractive manufacturing, you can also do small batches, but a lot of times it's used for cutting metal and a little more dangerous and needs some more time to figure out how to do things right and safely. You can do additive manufacturing on plastic type material. But plastics don't cut very well. They're kind of gummy. They get caught up in there and they just kind of melt sometimes. And cutting plastics with a tool, cutting it away, forming stuff is because of its temperature, which it melts. It's not the best way to do it. Additive works for lots of plastics. It's a really good way to fabricate in small batches. And nowadays, with a lot of stuff, people aren't looking for huge amounts of it. If you do, you might want just 20 of this, 50, 70, we're trying to tailor things just for specific situations, or it's called rapid prototyping. Figure out if this bottle works, what we need. Let's make it a quick, easy version of it, which you could actually print something like this bottle. Maybe not with that thickness of the inside, but you could make it, a little bit thick there, but you could print the outside of it. And that way you get it a lot cheaper to see if it fits what you're wanting to do with it. And that is one of the reasons 3D printing and these additive manufacturing techniques have really taken off in the last few years. Okay, now that's on page 7. If we flip over, they talked about some of the stuff with it. Formative, injection molding, casting, stamping. You can stamp things. Forging, put it in metal, make the sword and beat it out like the guys do in the movies and stuff. To temper the sword to make it stronger, and you give it to Conan the Barbarian. Those are formative type techniques. Again, expensive, and often used in high volume. Now, if you're doing casting, making those metals by hand, that's not high volume, but you're actually creating it, forming it together. Though it's that type of system. By the way, milling, they talk about CNC, that means computer numerical control. That is under subtractive manufacturing. That's using a computer to determine where to make the cuts. And think of it, you think of it as a 3D printer, acts like a 3D printer, but it's got a cutting head on it, like a drill, or it could be a lathe where the part turns and then the tool goes in and out of the part as the part is turning around really, really fast, or the parts come in like this and going across, or going in and doing a heavy drill cut. I like how they did cost in the book, that graph here on cost. Notice 3D printing, cost per part's fairly constant. So there's no sweet spot. Subtractive and with formative, there's sweet spots where it's good and the parts where it's not good. It's not good. 3D printing is fairly much over the range of it. Fairly constant. So what's the process to make a 3D printed object? The 3D printing process. That's what I want to look at now. Next, the 3D printing process. So first of all, you got to make an STL file. That's the file, basically triangles. You do it in CAD and it saves it in a certain type of format. That's the file that basically you look at and say, that's what I want to make. And it will make whatever you draw, whether good or bad, or well, it will try to make, I should say, whatever you draw. So can't blame any STL file except you. Now, once you do that, I want to say this STL file is made from, because I jumped ahead a little bit, from a CAD file. CAD is computer aided design. Think of this as 3D modeling. So it's made from CAD file 3D modeling. Okay. And once you do that, this STL file goes to the printer and it is, we're going to say manipulate STL file. So I put manipulate STL file, and that's where the printer gets, that's where you introduce it to what we call the slicer, and it figures out how to make the code to give to the printer to form the part you drew up, exactly how you drew it. Then once you get the STL file into the slicer, it's manipulated, it creates its own code for the printer, then you do the print. You run the program. And then the 3D printer squeezes out filament, melted plastic or whatever you're doing, nylon, whatever, and goes about and tries to form what you told it to make. So put in your notes, manipulate STL file, do the print, run the program. There we go. Do the print, run the program. All right. So they have some good pictures here in the book. Then once you do that, you then need to remove the print and post-process. You don't just take it out and it works. Sometimes you can. But lots of times you got to do stuff to it. Take supports off. Maybe there's some stringiness to it. A lot of times you'll see stringiness on these things sometimes where one little layer didn't print just right or a part of a layer didn't print just right. Maybe you need it smoother because these things aren't very smooth when they come off lots of times. Depending on what you're printing, there's different types of post-processing you need to do depending on the material. You want to try to do that kind of right after it, so if you know what you got is what you want it to be. Okay. All right. So that's the process. We talked about the types of manufacturing techniques. Let's look at the technologies here. And I'm on page 19 for this. And so I'm going to probably not use this because it's so much. I'll just hold the book up to you. Okay. Hold the book up to you like this. All right. So let's look at for 3D printing, there's basically about 6 different technologies, and you can see them in the book. Of course, we extrude, material extrusion. That's the FFF. That's basically that's regular 3D printing when we just inject plastic out, melted plastic out, hot glue gun, computerized hot glue gun. There's SLA and DLP. Lasers basically solidify a resin, and from that resin you make the part, and it makes it in layers. There's powder bed fusion, so basically you have polymer powders like plastic powder, and a laser, like wherever the powder is, a laser runs over it, fuses it together, puts another layer of powder, fuses it together, puts another layer, and it goes and does that, uses lasers to fuse. Material jetting, we squirt out material there. Binder jetting, we'll get into a little bit later, and powder bed fusion with metals. You can actually do powder bed fusion with plastics, but you can also do it with metals. And you see a lot are done that way. They swipe over a layer of powder, and it hits it with a very strong laser, melts it, and causes that powder to congeal in that one area. Slides over another layer, it lowers it down, slides over another layer, does it again, slides it over. So it builds it up. So when you're done, the part is down inside all that, a bunch of powder. You dump the powder out, and there's the part. Okay. So when you look at classification of techniques, I kind of went over that. Sheet lamination under here, know these techniques. Don't worry about sheet lamination. You see that some, but I just don't see it a lot. It's basically you're bonding sheets of a material together. Extrusion techniques, that's the FDM or FFF, that fused deposition modeling or fused filament fabrication. Should you know what that means? Yeah, probably so, or at least definitely be able to understand the process and what happens and what it means. The vat polymerization, I talked about it, using light or lasers to get that liquid to congeal, light activated polymer. A lot of the time, think of light activated resins. Now, a polymer is just like a plastic. Resins are kind of like glues. If you have a cavity or something or a crown, they'll put a gel on it. Then you'll a lot of times see them stick a UV light down in there. It looks purple or bluish in your mouth. And you say, and that's actually activating that resin to cure. When it cures, it solidifies. A resin, glue, polymer is just kind of a liquid plastic that also solidifies when it gets hit with those. Normally it's UV light. Okay. They talk about powder bed fusion. We'll get into that a little bit more. They use lasers, direct, or they call it selective sintering, selective laser melting, even electron beams. Electron beams, a beam of electrons is high energy stuff. I've done some work with those back in a long time ago. Down at a Department of Energy lab I worked at one summer. Those things will vaporize things. Those are, they see energy beams. The pew pews, those are energy beams coming out. These are continuous ones, and you can actually use that as a way of solidifying powders or even things that are in a liquid state. A material jetting, drops of material put on it. I almost think of it like an inkjet. Think of an inkjet, but the ink is just put on layers. You think if you did inkjet a layer, many layers, it would build up a little bit. Rather than use an inkjet for just ink, why don't we squirt something with a little oomph behind it, a little size. So it makes a layer, it lowers it, squirts it over again, it runs over again, prints it. It's like an inkjet printer in reality, but it uses things that aren't just nice liquidy, things that like melted plastics you can squirt over. Binder jetting, they talk about that a little bit. Liquids are bound. A liquid agent binds it. You put the liquid over the powder and it binds it. Of course, direct energy, that's just darn on it. Lasers normally are used for that. And I won't get into sheet lamination. Now, the material you can use with a 3D printer is next. These are the material groups. So these are 3D printing materials. So 3D printing materials, okay? That's what we're going to talk about. There we go. So the first ones are polymers. Now, I'm not a chemist. I don't pretend to be one. And I have not slept at a Holiday Inn last night. So Express. So I'm just going to tell you polymers are plastics. That's the basic definition I'm going to give you. Lots of different forms of them, lots of different types of plastics, nylons, PLA, ABS, PETG, stuff called PEX. I just redid a couple years ago, I replumbed my barn in PEX so it wouldn't burst if water froze in the pipes, because I had ABS plastic pipes burst on me, and that's not good when it's freezing outside and I have no water pressure in the house because that line is attached to the house. It was bad. That was not good. Now, these polymers are thermoplastics. They can be melted and solidified over and over and over. So you can actually recycle 3D printed material, actually, and some people do that. These polymers, though, they talk about it comes in filament. Filament is basically like wire. you would use for weed whacking, cut the leaves with the weed eater. That's filament. Resin is in a liquid state, and then powder. That's just, as it says, it's a powder of the plastic. It's very, very, very small little pieces of powder of balls of plastic, and it's powder. Depending on what you're doing with it, whether you're using FDM, SLA, or powder bed fusion type techniques, that's why you need the different type of polymer for that. So those are the states that it comes in. Thermosets melt. They start out viscous, and then heat does it, and that's the ones for light. I'm not talk too much about thermosets. SLA is done with thermosets, heat and light. So that you can have a thermoset and a resin. A thermoset, light hits it just from the heat of it, congeals it. A resin, the frequency of the light that's hitting it causes it more to congeal and harden. Metals. Yes, we can 3D print metals. As we get more into 3D printing of metals, traditional machining is going to go down. Machinists in 50 years won't be too many. There won't be as many needed. They'll still need some, and the ability to do machining is important, but 3D printing techniques via CNC, computer numerical controlled, basically computer controlled, something that looks like a 3D printer, but it's using these powder bed techniques, they're going to be producing a lot of the metal parts we're going to need going forward. You're still going to see some cutting of metal just with, but that's going to be more of a niche product. It looks kind of, and I say that kind of sadly because I know a lot of, I know machinists, and there's an art to machining. There really is. I'm fair. These guys are really good. It is a knowledge-based system that takes many years of acquiring through repetition and just cutting things to acquire the knowledge. You can do some books, but you can't learn to be a machinist without cutting a lot of metal first. You really need to be a good machinist. There's some other ones. You can do ceramics and composites. Composites are like fiberglass, Kevlar stuff. So polymers, I didn't talk too much about the under polymers. The sub bullet of that would be the thermoplastics and the thermoset. So you could put, thermoplastics and thermosets underneath polymers. But ceramics and composites, ceramics, brick, think of it as a type of ceramic almost. Printing of houses, they're massive 3D printers. It's been proposed to do that on the moon, taking lunar regolith and mixing it with a binding agent, something to bind it together, glue, whatever you want to call it, like concrete. And then basically you could print structures on the moon with that, possibly print them out of sand in the desert areas. It's interesting. There's people working on it. It's not there yet, but it's getting there, and they're really working on it. And for specialized application, it may work pretty good. I think that's all I want to talk about. They do some stuff here, some things printed with different materials, the same part, and that's it. Now that's a quick and dirty version of what I would have done in class. I'd have probably had more Q&A and stuff, but that's the idea. So I didn't put the 6 ways of things we do with 3D printing up there, but that's the idea of what I was going to talk about today. And so take your notes on it and make a JPEG, turn it in. I'm going to make a turn in for it so you can get a grade for it, and just turn that in, and my phone keeps dinging for some reason. And this will be class. Thursday, I will the Zoom for it I will put online, and so the Tuesday guys, you can watch that, turn in your notes. The Thursday people just show up, and we got lecture Thursday, and I will be there unless something happens I can't control. All right, take care. Night is out.